喂喂喂喂喂喂。
Okay, because we have tight schedule, so let's just follow the original schedule. Today, we are glad to invite Dr. Mingyu Liu to give us a talk about Cosmos World Foundation model platform for physical AI. Let me briefly introduce Dr. Mingyu Liu. As you know, Dr. Liu is the Vice President of Research in NVIDIA. He leads the team developing physical AI, and he is also an NtuEE Fellow and has published many papers in prestigious AI conferences. So I believe we are all eager to know what's the next. So let's welcome his presentation today.
Thanks for having me here, and thanks for the introduction. So today I want to talk about Cosmos World Foundation model platform for physical AI. So this has been an effort of many people at the media, and we are trying to produce useful foundation AI models to help physical AI. So before we talk about the topic, I want to first introduce my research group. The name of the research group is called Deep Imagination Research. So we have a website, and in the website you can see our latest publications. Like come here, you can see all the latest work on different topics. So if you want to know more about our team, please take a look. And we do hire interns, so if you are interested, let us know. Right. So deep imagination research is about generative models. We started this group long before GenAI was popular. When it started, our mission was simple. We want to use AI to convert novel to movies. Right. Just the writer write down some story, and the AI produce a full movie so you can enjoy. We also believe that the most important part of creating a game that you can play with is the rule, the setting. And we also envision that if we can design some rules, and then AI will be able to create a video games for you so you can play with your friends. So that was the initial mission of the team when we started. And we have contributed to this field a lot. So you can see this was the early day, maybe 2019, when Ian Goodfellow, the inventor of GAN, talked about the progression of image synthesis with GAN. And you can see, it's improved year by years. And the last three are all from NVIDIA, and I contribute to some of them. So it's improving, and we also did some open source cool demo. We have a very popular tool to do the photo style transfer. So you have one photo in a style that you may not like, but you have another photo that you really like a style, like the snowy like a scene, and you can transfer the style from one image to another. We also have a way to convert segmentation mask to images, so you can pen a little bit, and then you can have a photorealistic output. It's called Gauguin, was very popular. We also were the team that pioneered that deepfake. Actually, you have some skeleton, and you can start to generate like people dancing. You also see this Jensen demo, one of the year. Our CEO think that, why don't you create digital me so that I don't need to do the keynote, and we try, and it was what we did during the pandemic years. And later, foundation model become very popular. We help our company create Gen AI for company like Getty, Shutterstock, so that their content library can be used to make a image generator, 3D generator to kind of help people exploit their creativity, convert their description into images or 3D. It was a lot of fun. Yeah. So I think I pretty much fulfilled the initial mission that when the team was created. We want to do, convert your description to movie or games. And now my feeling is that this problem will be solved eventually and probably very quickly. You will see the latest result from Google's VO3. So it's probably will be solved. From last year, research had to be ahead, others, right? When the problem is about being solved, you don't feel the certification, it's the destiny. You want to find some problem that is less certain whether you can solve it or not. And last year, it was about the time that we think about what next. Yeah. So you may see this plot from our CEO's keynote. So the x-axis is time. So we are roughly probably in the middle of Gen AI. Gen AI. I think I probably don't need to talk about Gen AI. Everybody know what Gen AI is, right? We believe after Gen AI is agentic AI, and after agentic AI, it cannot be physical AI. Okay, agentic AI is about content creation, about chatbots, about digital marketing. You can create image videos. So what it does is that it convert your description to another description or image or videos, right? You can interact, you can have fun with. My definition of agentic AI, people have different definition. My definition is agentic AI is a better version of Gen AI. Not only can create content, but also can contain digital tools. You may heard about the OpenAI has a new demo called new product called Deep Research. Google also have a product. So basically, you start with a mission, right? Help me find the find the best trip to Italy in the summer, and the AI will go to use the web browser, a digital tool, to search for different website and then produce your summary to help you make your plan. So it's about a Gen AI controlled browser. I think probably many of you are using AI to help you with coding, right? And some of the more advanced tools also help you to do compiling. So you are seeing that AI help you control digital tools so you can produce a program much more efficiently. So I think agentic AI is more about a Gen AI that can control a lot of digital tools. You're gonna see how they control Photoshop, any tool, or any software tool you are using in different fields, even for circuit design. Gradually, they're gonna be an AI to help you control those tools to produce useful stuff. Right, so agentic AI control digital tool. Physical AI, I believe, is about control physical tool, control cars, robot arms, robots, and even factory, right? Those things that can perturb the outer world, right? Digital tool, you only perturb your computers. But if you can control car, it can be on the street. Control a humanoid robot can help you do all the cooking, sorting task. So we believe that it can be Gen AI, agentic AI, and physical AI. And why is Gen AI so successful, right? What makes Gen AI so successful is because of internet, right? Be a huge amount of data, so that AI can learn from, try to regenerate those data, right? Agentic AI will require you have large amounts of data about how humans use those digital tools. Okay, so it can be achieved. Every day you are using your browser. If Google, record your sequences, they're gonna have a training data to help them browse the internet. And many of you are using Photoshop. Adobe will be able to leverage your interaction to have a better AI to create content. When it comes to physical AI, if you want to reproduce the same success, we have in Gen AI and agentic AI, you need to have a huge amount of physical AI data, right? And there are two kind of important physical AI applications. One is self-driving car. The other is humanoid robots. Car I don't need to explain, right? Mobility is, everybody want mobility. When you become elder, you cannot drive a car, you probably want a robot to help, AI to help you drive the car. When it comes to self-driving car, the data problem is a bit simpler because you already have a car everywhere. They can collect data, right? When it comes to humanoid robots, it's actually harder because we don't really have a humanoid robot surrounding you. And the premises of AI is when you have huge amount of data, it cannot be successful. So robot need to be trained. The AI for robot need to be trained on huge amount of data so they can be successful. A successful robot is more likely become a product people willing to pay, right? But we don't really have robot around to collect data, so it's difficult to satisfy the condition to have huge amount of data to make a successful robot. So we have this chicken and egg problem. We don't have data to train robots, but we need a robot to be around to collect data. But yeah, you need to somehow figure out a way to break this cycle, right? Even when it comes to the self-driving car, most of the driving task is simple. Straight, left turn, right turn. The most challenging one is when you encounter a situation that is not normal, it's abnormal, right? Like suddenly there's a refrigerator falling down somewhere from the previous car, or let's I don't know, maybe an elephant on the road. Those things that rare scenario, how your self-driving car navigate, manipulate the car, maneuver the car during those rare scenario, the capability is the main bottleneck, right? Whether we can have a fully reliable self-driving car. So basically, you need a way to have a way to produce training data for self-driving car to produce corner cases. For robot, any cases. Humanoid robot, any cases. So NVIDIA Cosmos is a project we are working on, and we try to help physical AI become a reality by figuring out a way to synthetically generate the training data to train those physical AI agents. I hope I make my point clear. So we believe that to help physical AI successful, you need to have a large amount of data. And to produce large amount of data, you need to start with synthetic data. You need to leverage generative AI to produce huge amount of synthetic data. Okay, so this is a pyramid that we believe needed for have a successful robot. You need to have huge amount of internet scale data because even though you don't have human robot, right? But humanoid gonna be living in our environment. So all the YouTube videos you upload provide some clues how the environment would be for that humanoid robot. So there's a huge amount of internet data to help you to get some idea, about surrounding. That one we need to leverage. We also need to have synthetic data that's more from the robot's point of view. It different. You have a camera, hanging on the wall to a camera that is mounted on the humanoid's eye, right? So the viewpoint is different. So you want to have those synthetic data, and also some synthetic data for the scenario that is very difficult to create in the real world to train the robot. In the end, you want to have some in-robot data. Those pair with the action, the signal you send to the robot to make it move. In NVIDIA Cosmos, we try to learn everything from the internet scale data to help produce synthetic data. And we believe that we can combine all three, the in-robot data, synthetic data, and this foundation model to produce a physical AI agent that you can deploy on car or robots. So I'd like to show this video because, you know, robotics is challenging. And when you write a Gen AI code, when you make mistake, you know, it just hurt your computer. You rerun it, it's fine. But a physical one, it creates damage to your environment. It's very costly, right? So what you want is, you know, in some sense, we want to a cheap way to train those robots is to have something called world model, something like the virtual environment. They will react based on how the robot navigate in the virtual world and provide signal. So robot will be training itself in the virtual world, and it may make damage to the virtual world, but it's okay. Once it becomes robust enough, we let the robot out and start to interact with the real world. That's what we believe. Okay, so yeah, here I want to reiterate again. We believe that there are two important AI models you need to master to bring physical AI to a reality. One is the AI model live in the robot, and the other is the AI model represent the world, called world model. So the policy model, the AI model live in a robot, need to gain skill by first interact with the world model. Mature enough, go out and interact with the real world. Okay, so the mission of NVIDIA Cosmos is to help people who want to solve physical AI problem, the tools. So we provide pre-trained model, foundation model, video model, vision language models. We also provide example how you can post-train this model for your need, and also how you can curate your data. Everything I say here is open sourced. I cannot tell you where you can find the resources to help make physical AI reality, right? So we have aging society and less offsprings, so we need the people to carry on to make the society function. Okay, so we believe that we start with pre-trained model, and for different robots, they have different setups. So you need to do some customization, some post-training, right? Car usually have 12 cameras. A robot arm maybe just one camera, a robot dog maybe one camera, and humanoid robot, there are all kinds of humanoid robots, right? So, and each one have different camera location, so you want to customize those world model to be better tailored for that robot setup. Yeah, so since our open sourced, all the training script here, and all the in GitHub, and all the models are in Hugging Face. Since our first release in January this year, our model has been downloaded 1.8 million times. So there are many people really excited about physical AI and try to leverage it. All right, so let me talk about curate and search, right? So I'm gonna talk about how we curate video. So we believe that world model is a model represent the world, right? YouTube videos are probably the place where you get most of the video footage about the world. How do you learn the world from watching those videos? The first thing you need to do is to curate a huge amount of data sets. And to curate a huge amount of data sets is a challenging problem. So, and you also need to decide what the composition of the scenes you want to put in, right? To learn about the real world, you probably don't want animation, manga, right? Those are not real. So you want something close to what people will experience, or humanoid robot will experience. And this is our composition. I can skip this part. And usually you have a long video. You first want to divide it into chunk, so that there's no, like from scene A to scene B, so it's physically possible, right? You cannot say a humanoid robot is here, and next moment it's in near the beach, right? It's difficult. So you want to find a boundary, and some video are not easy to use. They may have too dark, nothing to learn, right? So you need to do a lot of filtering to remove them. And once you have a set of good video, you want to annotate and describe what's in the video, right? So you try to build a relationship between text and video. So later you can use them to generate, let's say, hey, show me a kitchen that make ramen, right? So you need to build out this semantic relationship. And I'm gonna skip this part. Yeah. Okay, let me talk about the models. So we have two kind of model. One is for synthesis. Those are video model that can generate videos based on text, image, video to simulate the world. And there's another set of model is for understanding. Try to explain what inside the video. In the synthesis part, we have two kind of models. One is called Cosmos Predict. It's a future state prediction model, right? Given the scenario that look at me, a person, and the command is walk to the other side, and then you type text, the speaker walk to the other side, and then you synthesize me walk there and come back, right? So that's predict. Transfer is developed to leverage existing 3D engine. So you have played many video games. They do have a 3D world and you can control, right? But their rendering is not necessarily like what in the real world, right? In transfer, what we want to do is to use this video model to map from this virtual world that is gaming-like to a more realistic world that a robot might encounter in the real life. And yeah, so these two models. So, and these models are related. So we start with the predict, the video model, the future state prediction model, and we can post-train it to become a transfer model, and both of them can leverage reason to improve. I'll talk about it later. Okay, predict. Given the current frame, the description during the future. This has many applications. One is policy evaluation, right? So once you have a robot policy, they can do cooking. You want the robot be able to cook on all kinds of different kitchen, right? And how do you come up with 100 kitchens to verify your robot can cook on those many kitchens? You can use this predict model to synthesize all sorts of kitchen, verify it worked, and then find a few real kitchen to do the further testing, right? And there are also applications like in synthetic data generation and model predict control. So to build this video model, we use diffusion transformer. How many of you know about diffusion model? Okay, cool. So, since 2012, there are many different AI models, and nowadays only two major ones stay. One is the GPT model, next token prediction. The other is a diffusion model, right? Gradually remove noise. Both of these models have an interesting property. They break a challenging big problem into small problems and solve it one by one, right? In next token prediction, you predict token by token. In diffusion, you do noise step, remove one by one. Okay, for video model, you get better result with diffusion model. So the way video model work is you start with a pure noise, and you gradually remove noise based on your text description. The text description can be a man open a window, right? And based on the text description, you gradually remove noise, and you start to see a kind of some noisy version of this video, and keep applying, and you eventually have a high quality video. And the individual noise removal state is achieved by something called a diffusion transformer, and here is the architecture we use, also a very standard architecture. So the top, you have the input noise token, which are your current noisy observation, and you go through some layer known, self attention and cross attention, where close attention, you leave text the prompt, and then open the window to help you remove noise, and eventually you have a cleaner version. In the diffusion model, so you use time to determine the noise level to help you estimate the noise level to do a proper denoising job. Yeah. Okay. So, and this is what you can do with our release the Cosmo predict model. You start with the first few frames. You can generate the future. And so, earlier we used text prompts, the first frame, we generate the future. You can also use camera trajectory, right? To post-train the model with some video where you have gone through camera trajectory. Once you finish this post-training, in the test time, you can change the camera trajectory like in virtual world, and you can achieve better world generation. So here is example, you can do moving forward. You start with one image and you say moving forward, backward, left, and right. Then you can navigate in the virtual world. Here's another example. Go to the supermarkets. These are all generated by our Cosmo PD1 video model. And not just one view, right? Some camera have multi-views. So you can actually start with this pre-trained video model and make it a multi-view video generator by using some video data set you have that is with multi-view and registered views. And this one example, your car, and you can see both the front, left, right, and then you can simulate how this car move forward in a snowy day. In addition to generate multi-view, you can also let the input control on the camera trajectory. So when you steer the wheel, it's like really navigate in the virtual world. So the radar here shows that how the car gonna move, and you can show, right? So think about you can show this to your driving agent. Make sure it does well in the virtual world before putting in the real world. Yeah, you can also put down instruction and action skills part. In the transfer part, play this video. So yeah, we believe that you have a virtual world that is CG rendered, and we want to leverage this Cosmo model to make them more realistic. So yeah, so basically we use a multi-control net that can take multiple modality input and make them more realistic. Yeah. The good thing about starting with 3D engine is you can do better control where the object should be, and the simulation of the world can be based on physics engine output, so it's grounded by physics. Yeah, so you can also use LiDAR as input, and the same input you can map to different driving scenario under different weather conditions. Yeah, basically you can think about synthetic to real case. In the past, I mostly show like cool animal, dogs, others, and now I'll focus on physical AI. I'm mostly showing robot arms, cars. Yeah. So what we do is a control net. So you start with a backbone like the one in the lab, a diffusion model, and you add a control branch. So we use multiple control branch. So one can be handling edge input, the other handle depth inputs. And before they come into the main branch, we have a way to control the inference from that particular modality at that pixel location. And this gives us some application that's very useful. I'll talk about it later. So here's one example. So we have a video. The top one is a video. We extract the candy edge, depths, and do the segmentation. And we regenerate some similar real data, okay, by using this transfer model. And we want to keep the subject the same, but the background also similar but different. And through this multi-control, we can achieve it. Because we know the foreground object is a human, so we can use the segmentation map to measure the inference for the color and edge. The color and texture for the foreground object is high, and for the others are low. So the control weight here, white means 1 and the black means 0. And by doing this, we can resynthesize the video of the same subject on the slightly different background. This helps you create more variation for your training data to help train your robot. Here's another example. Yeah, so this is example of using lab is the input, the edges and the segmentation map, and you can generate the released video. And here is you start with the LiDAR map on the top, and we call it HD map, where the rectangle, the box mean car, represent car, and based on the input on the left-hand side, you generate a real driving video. So you can write a very simple simulator to have box moving around, and you can create realistic driving scene. Okay, gonna skip this part. Okay, so let's talk about the reasoning model. So reasoning model become very popular, since OpenAI released their O1, and early this year DeepSeek had their R1 released, become very popular. What it does is you have a test prompt, and before you normally when you interact with early version of chatbots, you ask them something and then give you answer, right? In a reasoning model, before give you the answer, they will do the chain of thought generation. They generate their internal thinking, how I gonna answer this question, and gradually come up with the answer. Actually, I found it very interesting. So it's like if you decide to do something, before you do that, you make plan. Usually, you have better chance of succeed, achieve your goal, right? When you make your plan, you write down what you are thinking. So it's very similar to the chain of thought process when you do the reasoning model, right? For this one, if you can, for the reasoning model, you can take video input. You can leverage it to explain, to reason about what they see in the video, to help you create better spatial understanding about surrounding. And we work on this one because we believe it's very useful for physical AI, right? So for example, I'm a robot. I want to go out of this, this conference room, right? So I might look around and see, those looks like a door, right? And there's a metal bar on that. So it looks like something that I need to turn, right? And I can start to come up with more detailed plan how I want to execute, and then give you a better, eventually help you with the planning. So I'll show you, we built a model called Cosmo Reason. It's a vision language model, and here I'm gonna show you the video. So it can be used to tell whether a video is synthetic generated or fake. Right, this one is clearly fake, right? Because the door open, and this moving forward backward, and it's clearly backward. Car doesn't move that way. And we also train the robot to train the AI to piece multiple break down the image together. Yeah, it's open source. Can download and have a try. So what it does is it takes input video and it tracks features through a visual encoder, usually VIT, and the loads become video token paired with the text token into a LLM and generate output. The output starts with the chain of thought thinking, and then eventually you have answer. So that's what we do. The difference, everybody is building vision language model, right? The difference is that when we build this Cosmos Reason 1 model, we want to solve physical AI problem, right? We want to find a way to train the VLN so that it's better for robots. So we developed two steps. One we call physical AI supervised fine-tuning, and the other is called physical AI RL. So we start with a pre-trained multi-model LLM that's maybe understand graph or some kind of simple drawing, a general vision language model, like maybe ChatGPT, and we fine-tune it to make it more appropriate for the physical AI task through these two stages of training. Physical AI SFT, physical AI RL, and you have Cosmos Reason. For this physical AI data, we focus on two kind of training data. One is called physical common sense. The other called embodied reasoning. In the physical common sense, we break down the common sense for the physical space into three parts. One is the common sense about space, time, and the fundamental physics, right? And we have a subcategory how we believe that for space you need to understand relationship, affordance. For time you need to understand causality, planning. And for fundamental physics, you need to know about like a basic one as Newton dynamics and also anti-physics. You need to know that people don't fly, those kind of things. And based on our belief that a physical AI model need to have this capability, we start to curate training data sets to train the robot. So it's very different. So in the past, because before Gen AI was very popular, people focus on developing algorithm to kind of achieve their goal. And now everything is transformer, either net token prediction or diffusion. Sometimes the best way to achieve your goal is to focus on data. And to find the right data to train your model also require a lot of AI. And then we gradually shift more and more on methods to find high quality data that can help our AI learn about spatial relationship, also things, and to improve the model to make it useful. Another thing is about embodied reasoning. So we focus on training tasks as a robot to process complex sensory inputs. The input is not a regular video content allow scene change. Also predict action effect. What's gonna happen if I kind of kick the chair? Respect physical constraints and learn from interaction. So yeah, I'll skip this part. So we basically start with pre-train the vision language model, and based on what I said earlier, the common sense and the embodied reasoning, we curate data to do the SFT training and then do RL. And you might heard about recently a very popular algorithm called GRPO. It's used to train the DeepSeek. So it's called grouped reward policy optimization. So basically, if you ask the AI a question and the AI tried 10 times and only one time it was right, and that sample is very important, right? It tells you this is a challenging problem, the model is still not yet mastered, you want to make it very important. On the other hand, if every answer is correct, like the one in the bottom, then it's probably not very important. So GRPO help you to determine which data is more valuable to make you train more efficiently. I'll skip this part. And we use all sorts of things to do our training. One thing I found interesting is we ask the AI to reason whether the video shown to AI is played forward or reverse. Right? So if I'm putting water to the floor, the water is coming down, right? If I play reverse, then you see the water coming up, right? And it's very easy to find such video. You download any video, play forward, reverse, and you can use ILO as the model to reason. And we find that by applying this training, the VLM, the visual language model, the AI, can better reason about the dynamics, the causality. Yeah, so ask you a question. Is this video forward or backward? It's not easy, right? So how about this one? How about this one? Yeah, all of them are backward. Yeah. We also try this. We put multiple frames from different video into a single one, and ask the AI to find similar frame, similar to the first one. So force them to focus on special relationship. All right. Typically, when you do reinforcement learning, right, doing GRPO like reinforcement learning is a challenging implementation problem. So it usually require you have many GPUs, and you have to divide the GPU into two groups. The first group focus on something called rollout, to roll out different features. And from those rollouts, you need to do the GRPO to determine which rollout is more valuable. Okay, and once you have those determined, those generated data had to send to the second group to do the regular training. And once the model was trained with the update with the new data, you have a new weight, and the new weight had to be sent to the first GPU group, so that you are using the latest model to do the rollout. And the two things you send are actually, one is simple, the other is hard. Which one is simpler? Is data is simpler or model is simpler? Okay, so actually I can help you. So if you are training DeepSeek has about 671 billion parameters. So it's much bigger than the data, those text data you send, right? So building this training system, the most difficult part is how do you handle, update the model weight on the GPU group, take the update from the first one, yeah. And we develop a training system to make it more efficient. So VRL, how many of you heard about VRL library from ByteDance? You know about, right? So it's a very popular reinforcement learning library. V is a volcano engine, is their cloud, and they have our library. We built our library which is more efficient, 2 times more efficient than them. So, and it's open source, you can use it. Yeah, and the way we achieve it is through kind of heavy optimization, but we also realize that the rollout doesn't need to be with the latest weights all the time. Sometimes it can be delayed, right, from the previous iteration. It's not the best, but it's actually, you might become 10% less efficient in terms of total amount of iteration you use to train the IO, but because you save the communication time, you actually can train this model faster. Yeah, there's this involves code design. You need to know the AI algorithm. You also need to know the system. Put them together, then you can start to build very efficient training system. Right? Conclusion. Okay. So since I'm moving very fast, in CES we released actually Pretty 1, now Pretty 2, and tomorrow we're gonna release Pretty 2. And in GDC we release Transfer 1, quickly we're gonna release Transfer 2, and Reason 1 and Reason 2. So you know, in Gen AI fields are moving very fast, so you need to keep updating your model. And I want to come back to this initial slide to show you that we believe next, you know, after Gen AI, gonna be agentic AI and the physical AI, and we want to start to create the success conditions so that we can solve the physical AI problem. And in this Cosmos family, we have pre-trained models, post-trained weight, and the curation pipeline. And thank you.
Thank you for the inspiring and insightful talk. Maybe we can have several questions. The question can be described in Mandarin or in English.
Thanks for the inspiring talk. As you mentioned, physical rules are important in real world, like gravity or acceleration. So my question is that, how can we make sure that the synthetic data generated by word models does follow these physical rules? And yeah.
It's a great question. So, so we have two kind of two approach. One is purely generate video. You know, the other is by converting CG rendered outputs from 3D simulator to make it more realistic. To meet the first, to become physically grounded, the easiest way is start with you know, 3D simulator, right? You can use you can simulate you know, gravity or things, and but the output is not realistic, and you use this you know, video model to make it more realistic. That's one. This one still have a problem because to create those 3D assets is not straightforward, right? So you can have few high quality one, but it doesn't scale, right? So when we come to the video model that generate everything from scratch, in the beginning it's challenging, right? It's because you just in the video try to mimic the pattern, right? Not necessarily you really know the gravity. So what we believe is that you can start with this one and use a reasoning model to reason whether the generated video follow the gravity, right? So you start with some video model, it may generate 10 times, like what I say, GRPO, 10 videos, and only one of them follow gravity, right? You have a critic based on the reasoning model to decide. And then you have a RL signal to help your video model, right? So we believe this is something needed. And I think you need use transfer to get initial points, and gradually use, you know, this more scalable one to get to the diversity you need in order to put the robot reality. Yeah. Great question. Thank you.
Any other question?
In the physical world, there are lots of sense, like you cannot see, or like some smelling, and like the or other. The visual language model still based on the language to guide the vision feature. So lots of physical attribute we cannot actually describe by some actual language. Is there any method to make this Cosmos world more realistic, to make our AI to make more powerful? Great question.
So, so I believe the development of humanoid robot gonna come with different stage, right? So I would be very happy start with a robot that can do simple navigation task and pick up, and place task. And those robots may not understand the emotion or can sense the surrounding, but those robots are useful, right? And I think once we start to achieve those milestones, and people will start to think about how to add, other modality in, right? And not just smell, there are more practical things. We haven't modeled, tactile sensors, right? I can manipulate the microphone without, seeing it, right? So those things we haven't mastered it, right? So I'm not claiming that Cosmo is the give you everything to solve the problem. What we want to achieve to contribute on pilots, we have we have spent years. We work on videos for years. We want to contribute that part, and definitely we need other people and many other people to work on, hearing, audio, tactile together, so then it will be more useful. Yeah. So the video model, the world model we are modeling are the visual world. I hope I answered your question. Yes.
在工厂的自动化
是
很多一般的人就是已经用人工在做嘛，我可不可以照射所有的 video？ 比如说同样的工厂，在好几家的工厂，我就有很多 data，right？ From that data, can I create 你那个3个 model， 包括 predict 那个transfer reasoning and then 那个
，OK，
可不可以这样做？然后你就可以 create 一个 robot， 它可以 automatically 去做那些事情。
是 ，OK。Let me explain the question, right? So, question is we have many factories, and can we leverage factory data to create the transfer predict reason model to help those robots, right? Yeah. The answer is yes, I believe so. And we will start with a pre-trained model that see many things, and then fine tune on those video collected from those factory and better match their scenario. And usually, you want robot arm those in the factory to do. If the robot already master the task, you probably don't care. You want it to generate to other tasks, right? So start with the pre-trained one, give you the diversity you need. But there's one question is usually in factory you need a high precision, right? And the high precision part is still a challenging for generative AI. Yeah, and I do believe that the model need to further improve in order to meet the precision required for factory. Yeah, the factory one, the complexity of scene is easier, but the precision required is harder. So it's a different problem. And also another problem is most of the factory doesn't like to put their factory video in the internet. So it's they have a low IP on how they put the station together. So it's difficult to find those data to begin with.
Yeah, but it all depends on how many data do you need it, right? I mean, because you can have every day you have 100 workers working on it, and doing the same thing, so you can have a lot of video just within your company or within your supply chain kind of effort.
So how many video needed to achieve the goal, right? So often the diversity is more important than the quantity, right? The same person do the same thing 100 times, but you probably will prefer 2 people doing 2 different things, right? So it's about diversity. And how many are required also depends on the complexity of the scene you want to model. And I don't have a good answer, so it's very empirical. And usually when the model is better, you require less data to do the training, fine-tuning.
So does people try to do this way?
Yes.
To automate the factory, and they create a robot to do those kind of things. Have anyone tried that, or have you seen some of those?
I have seen people try that. I cannot tell their names here, but people do try. Yeah.
You talk about 3 stages, starting from generative AI to agentic AI, and then to, physical AI, right? You can imagine that in the 3 stages, you will need more and more data. And also, generative AI, you really don't need a lot of supervision or tagging. But the more you do, especially for reasoning, you will need a lot of varieties of data in order for you to do good reasoning. So, do you have something in mind what to do there? I saw teaching even young child to do reasoning is not an easy thing, right?
Yeah.
So how do we teach a robot to do something like that?
So it's a great question. So we show the figure that's
The 3 stages.
yeah.
Yeah.
So data required is higher and higher, but sometimes you can from generative AI to agentic AI, you can start with a powerful Gen AI model, and you can focus on collecting the digital tool usage data. When it comes to physical AI, we believe you can do the same. You start with a powerful agentic AI and then focus on the new data you need to collect. So it's accumulative. So you can leverage the data after you collect in the past to make it better, right? So there's one thing. And the other is how do you get enough reasoning data? I'm working on synthetic data to help training physical AI. But a lot of research I'm doing is actually how to use synthetic data to help me train a better AI to help generate synthetic data to train another AI. The synthetic AI has become more and more important, right? So how do we generate a lot of reasoning traits without requiring human to do the label,
Yes.
right? So that is really the key. And we found those open source like DeepSeek, those models, they can do common sense, regular reasoning is a good starting point. And those models, when you fine tune a little bit on the reasoning on your specific domain, it often generalize, and you can create many, and some of them will be bad, some of them will be good, and you keep the good one and continue improve. So you are doing this bootstrapping and eventually to make things better and better. Yeah. So.
Do you have some prediction for the timeline for this to happen?
I don't know. It's very exciting, but also scary, right? Yes. So when you really have a robot that can do most of the tasks. Yeah. So anyway, I think it's an interesting problem to solve. I don't know how long it's gonna take. And I think we like this problem that's uncertain. If too certain, then probably not something you want to spend your time on research.
One related area is something called trustworthy AI.
Trustworthy
right?
AI.
As you were saying that it can be scary. So how do we build some of those mechanisms so that we can have trustworthy AI that we can use daily?
I think it's require time and regulation. So I live in San Francisco area. We have many self-driving car. No people in the car seat. Driving Waymo, yeah. You can see just on the highway, just another car come. There's no people in the seat. In the beginning was a bit kind of overwhelming, but now I'm used to it, right? So, yeah. So it's I think people adapt, and we need to make sure people are protected. People are fully adapt to have those robots surrounding us. Yeah. So, and trustworthy AI is important to build trust, so that you buy time, so that those things can be integrated to our society.
I can share with you one real experience. In Phoenix, you can take Waymo from the airport to downtown hotels. So I have taken one time, and Waymo was very good in avoiding accidents. But at the end, they don't know how to stop because there are a lot of cars parking illegally at the hotel. So we end up circulating the hotel, and the car could not stop. So they end up having called the headquarters to supervise the car to stop.
So you help me explain an important point, right? You need a synthetic data to generate those rare cases so that your robot can be stronger.
It's a human mistake.
Well, but human mistake is the corner cases.
Yes.
Yeah. So and once you have these corner cases, you want to generate many similar corner cases. Yeah. Thank you for the question.
Okay. Maybe the last question, okay?
Yeah, so thanks once again for your interesting talk. I have somewhat deeper question, but probably not really related to technical things. So what do you think is the end goal of the physical AI? And is that we want the AI to learn a good world model and to perform actions or reasoning similar to human? And to what extent do you think physical AI will mimic human? And is it that we have to copy or clone 100% of the human capabilities to the AI? And what's the reason of doing so in your perspective, or probably your company's perspective?
First of all I'm talking here is I'm representing my view. I don't represent my company.
Okay, right. So based on your personal view, like, what do you think is
sure? I
better?
Personally, an agent. I have 2 young daughters, and I do want to live with dignity when I'm very old, right? So I feel with the robot, they can solve some of the tasks. I will become more independent. I feel that is pretty good. And I feel those robots, they can really share some of the workload to, clean the yard, garbage, do the laundry. That's gonna be very helpful, right? And you can more time to do other stuff. And there are also tasks that are very challenging. You do want robot to execute instead of human, right? Whether you want a robot to be as smart as human being, it really depends on the applications, right? So, and I think people will try. And people will find applications, and they definitely will have some negative effect. But I think as a society, we will adapt and figure out to regularize those things to make them a positive, components to our society. Yeah. So I'm optimistic. It's scary, but optimistic.
Right. Thank you.
Okay, we are out of time. There are still some questions cannot be answered, but we encourage everyone to keep an eye on the trend of physical AI. Maybe next time we can invite Dr. Liu to tell us what's the next time. Okay, thank you for your active participation and engagement. And let's give Dr. Liu a big applause. Okay, we would like to take a group photo, so just wait for a moment. Participation. 要讨论的老师请到博理馆114。